Hello fellow mathematicians, this is Ms. Backfish and I am here to go over some characteristics of polynomial graphs with you. And this is a problem that you see right here that we did today in class. Some classes I think we finished this one, some classes we didn't, so I thought I would go ahead and show it on the screen just for those who wanted to go ahead and see the answers. But what I'm really here to do is work through this one, number 3, and also number 4 with you, because I think I want to show you some things about Desmos, and when we have to do, sorry that was a cat, when we have to do the graph ourselves from scratch, what we're looking for, and of course that's better shown on the computer. So with that said, I have opened up a screen in Desmos here. And I'm going to move this down so you can see that it's just Desmos, DESMOS.com, and this is the graphing calculator. And I'm going to type in our equation for number 3, which is in function notation, which means that f of x that you see. That is red, f of x. It's not f times x. It's just a way of, it's kind of like our y equals. It's a way of saying this is what I'm doing to x. And I'm going to go down to this keypad down in the corner and use it to type my equation. I've got x. This little a to the b allows me to put to the third power. Then I click to come down out of the exponent. And I've got minus x squared. There is a button for square, so I can just use that. Minus 5x minus 3. Alright, so here is my equation. I can go ahead and pull that down again. And this is the graph of number 3. So on number 3, we're having to find the graph and we're having to figure out all those things, all those characteristics about it. But here's your graph. So let's look at what I see. I see an x-intercept here at -1, 0. I see the y-intercept at 0, -3. I see another x-intercept at 3, 0. This point, this x-intercept, also appears to be a local maximum. It's the highest point in that area. And this point over here appears to be a local minimum. So these are all things I'm going to need to use as I'm looking at this graph. If you have not already, hit pause and go ahead and get out your Chromebook, go into Desmos, type in this graph, or type in this equation up here, this function, and make sure that your graph looks like mine. And make sure you have your notes open to, I guess this is page 5 of the notes. The page, same page I'm on, where number 3, example number 3, and that you have something to write with. Okay, so hit pause and make sure you are ready to figure this out going forward with me instead of just watching me do it. Okay, so back to the notes page. Before we start plucking valuable information off of that graph, there are a few things here that I can tell just from looking at the original equation that I don't need to graph it to know. The degree is one of them. The degree here, it's the biggest exponent, it's 3. Okay? And so, and we can write 3 if we want to, but the big matter, what really matters to us is that it's odd. Okay, so it is an odd degree. That tells me something about the end behavior. It tells me that the ends are going to be pointing in opposite directions. Just like a line, which has an odd degree also. The other thing we need to know for end behavior is that the leading coefficient is positive. There's like an imaginary 1 there, but there's not a negative sign, so it's a positive 1. So if it's like a line, if it's odd degree and positive out front, then that's kind of like a line with a positive slope. It's going to be down on the left and up on the right. And the way we can write that is, this says as x approaches -infinity, that means on the left, it is pointing down. F of x is going to -infinity. And as x approaches positive infinity, means on the right side of the graph, it is going up. The graph is pointing upward or moving upward. And so that's positive infinity. So there's one thing I can go ahead and write without needing to see the graph, just from what we know about end behavior and degree. Excuse me. Now, another thing we can figure out without having to see the graph is domain. Because for all polynomial functions, we said the domain is always going to be all real numbers. And this is how we write that in interval notation. Everything from negative infinity to positive infinity is fair game. Now range, sometimes it's all real numbers, sometimes it's not. Here's when. If you have the ends pointing in opposite directions, meaning your degree is odd, so that one end is going down forever and one end is going up forever, then all y values will eventually be passed by this graph. So that means all real numbers. So if you have an odd degree polynomial, your range, just like the domain, is all real numbers from negative infinity to positive infinity. And what about when would it be different? Well, if your degree is even, then you have a polynomial that turns around kind of like this one above here. This one has an even degree. Both ends point up. Excuse me. So that means we have a lowest y value. The y values never get any smaller than this one right here. So that's why our range was limited by that. The lowest y value is this one right here at the bottom at my absolute minimum, negative 6.914. I think that needs a 914 right here. And on the top, I've got arrows. There is no limit on the top. Okay, so let me just show you a real quick kind of cheat sheet that I made up during guided study today to summarize domain and range of my polynomial functions. Domain is always going to be, for all polynomial functions, negative infinity to positive infinity. The range, it depends on your degree. If your degree is odd, like in this one we just did, number 3, or the one we're on right now, then it's also going to be all real numbers, because one side of the function points down forever, or one side of the graph goes down forever, and one side goes up forever. So it's going to cover all the possible y values. It's when the degree is even that the range is special. That's when the answer will depend on your absolute minimum or your absolute maximum. And in this particular case over here, I have an absolute minimum. So I look at this number, and this number right here, this y value, is the absolute minimum. So that means the smallest y value you could ever have in this function is negative 3. This right here is interval notation, and it always goes from smallest to largest. So the smallest y value is negative 3. It gets a bracket because y can be negative 3. It is right there. That point has a y value of negative 3. And then, on the other side of things, the largest y could ever be, well, it just keeps going forever. There is no largest. So we say it keeps going to positive infinity. Over here, this one opens downward. This has a ceiling. We could think of this like a floor. And this is like a ceiling. There is a highest that y can get, and it gets no higher than that. It never goes above that. So the lowest, always smallest to largest, the smallest y value, well, y can be smaller and smaller and smaller and smaller toward negative infinity. So there is no smallest y. It's from negative infinity, it's going up to the largest y value, which is right here. It's that 5. And again, it's a bracket because 5 is included. We have a point that has a y value of 5. So it can get up as high as 5, but it's never going to go any higher than that because it turns around and starts coming back down after that. So this is just a quick summary of domain and range on your polynomial graphs that you might want to pause and write down yourself, or take a picture of, or something like that. Okay, now for all these other things that are asked, we're going to need the graph. I do want to point out to you that all of these, the min and the max, any minimum or maximum, and that's any kind of minimum or maximum, a local minimum or maximum, or an absolute minimum max, any of those are turning points in my graph, and that's where things turn from being an interval of increase to decrease, or decrease changes to increase. So these all go together. You need to know your maxima and minima, that's the plural of maximum and minimum. You need to know those turning points in order to find your intervals of increase and decrease. Let me go ahead and point that out, that those are turning points. Okay, so again, I made a little cheat sheet for you here. Okay, we're going to start by finding our turning points if we want to know when our graph is increasing or decreasing. Okay, I don't know why it says this. These, start by finding your turning points. These is what this should say, are also known as your local maxima or minima. These. All right. So here's a turning point. Here's a turning point. Here's a turning point. Here's a turning point. And on this particular little picture, I didn't even draw the graph, and I went ahead and found the points for you. I said, let's pretend we already know what the points are. So each of these is a turning point. I'm going to highlight my turning points. Highlight turning point, turning point, turning point, turning point. Okay, if your turning point is like a little mountaintop, if it's higher than the points around it, that is a local maximum. And if it's lower than the points around it, it's like a little valley, that is a local minimum. Now, on this graph, because the two ends point in opposite directions, this one goes up forever, this side goes down forever, there is no absolute maximum or absolute minimum. Remember, that's when we have a situation like this where the two ends both point up, or they could both point down. You're going to have an absolute bottom of the graph or an absolute top of the graph. But here, they're just all local. It's also called relative, local or relative maxima or minima. So these are my turning points. So what you're doing is, remember, we read a graph from left to right. So it's like you're tracing it from left to right. So start on the left, and you're tracing it. And if you are going upward, if your pencil is going upward, then that is an interval of increase. If your pencil is going downward, that's an interval of decrease. If your pencil is going upward, increase, downward, decrease, upward, increase. So those little bitty arrows I drew, that's the direction your pencil is traveling. And if it's basically up, and it can be up to the right, and it's down and to the right, but if it's basically more up than down, or more down than up, that's when we have an interval of increase or decrease. Okay? So this particular graph, I highlighted where it's increasing in yellow. So this is increasing here, and here, and here. Now, what we use to separate those are all separated by turning points. And what we look at for the turning points when we're going to describe where is it increasing and where is it decreasing, we look at the x value. Okay, so I'm going to use -7, -4, 0, and 3. So if I'm doing increase and decrease on this graph, and these are my turning points, I'm going to say it's doing one thing before it gets to -7. Well, before it gets to -7 means from -infinity to -7, because I'm going from left to right. So I'm going to start with -infinity and say from there to -7 it's doing one thing. Then from -7 to 4 it's doing one thing. And then from 4 to 0. And it just alternates back and forth. If it was decreasing before that turning point, it will be increasing after. If it was increasing before it, it'll be decreasing after. So notice that these all are tied together. Here's an interval. If it stops doing this at -7, it stops increasing at -7, well, then that's where it starts decreasing. And then it decreases all the way up to -4. And if it stops decreasing at -4, well then, boom, -4 is where it starts to increase. And it does that to 0. So if this interval is closed out by 0, then this next interval for decreasing will start at 0. All right, so let's look at that with the graph that we have in front of us. The nice thing about this graph is it only has 2 turning points. If I start on the left side of the graph, and my pencil is tracing it, then I am moving upward. My arrow is moving up until it gets to the first turning point, which is right here. So I'm going to use that x value to say my first interval is from -infinity, as far to the left as I can go on this graph, until -1. And it's increasing between those, because as I'm going up, as I'm tracing from left to right, the farthest point to the left is over here. This is my pencil's moving up. That's increasing. Now it changes, and now it's going to be decreasing. So it's all through here, it's decreasing. My pencil's moving downward until it gets to the next turning point. So I'll use this x value, 1.667, to describe this middle interval. And then this will be the start of the last interval. The last interval, it was decreasing coming into that point. And now it's going to be increasing again going out of that point, and this one goes on forever. Okay, so sometimes I like to go ahead and just transfer the graph to paper, and it can be a very rough sketch like mine. Mine is not going to win any awards for beauty. And on that, just kind of write on there if I want to, that this is where it's increasing. This can help me that I can actually trace it. When I was drawing this, I am moving upward, so that's increasing. And then while I'm continuing to draw it, now I'm moving downward, so that's decreasing. And finally turn, and then I'm moving upward again, so this is all increasing. And we're going to use the x values of our turning points as the sort of boundaries for that. So what I'm going to write is that I'm going to say it's increasing from negative infinity up to negative 1. And we use the union symbol as an and here, especially when you're doing delta math, you'll need that. Okay, and it's also increasing over here, so it's also increasing from 1.667 to positive infinity. All right, now where is it decreasing? It's decreasing from here to here, so from negative 1 to 1.667. Only one place it's decreasing. All right, so let's fill this in. I didn't ever say what my max and minimum were, did I? That is a relative or local max right here. And this is a relative or local min right here. Now, when I'm asked what is the maximum or minimum, that's like maximum or minimum height. So the local max is the y value here. And here's the local min. Is the y value. So they're the same point, but we use something different when we're talking about max and min than we do for the intervals. So the max and min, I have a local max at 0, and my local min, I have a local minimum of negative 9.481. Now sometimes we like to write these as points, so you could say this is at negative 10, or you could say that's at 1.667, negative 9.481. Sorry that I bled over here. But the real actual max or min is the y value. All right, so keep that in mind. So we said for our intervals of increase and decrease, I'm just taking this and putting it in here. It's increasing here and there, and it's decreasing in between those. Okay, so notice you're going to have some of those same numbers there and there. Now, the other thing that is related is our x-intercepts will be related to our intervals of positive and negative. And when we're talking about that, we're talking about where is the y value positive or negative? Where is the y value above or below the x-axis? So, here's a little quick note sheet for that. We need the x-intercepts. We need to know the x-intercepts because these are where it changes from positive to negative or negative to positive. Why? Because positive means above the x-axis. Negative means below the x-axis. How do you get from above the x-axis to below the x-axis? Well, you got to pass through the x-axis. So those points, the points where it passes through the x-axis, the x-intercepts, those are important to us because that's where it changes from negative to positive, or positive to negative, so on. Okay, so then I'm just going to look at when is it above the x-axis and when is it below the x-axis. Notice these are not, the maxes and mins would be here, the maxima and minima. We're not looking at those here. For positive and negative, we're just looking at the x-intercepts because we want to know where it crosses over from negative land, below the x-intercept, into positive land, which is above the x-intercept. And I think it's fun to kind of highlight it and look at, okay, everything above the x-axis, it's here and here. Below the x-axis, it's this part, and this part. So this is how I would write the answer. And again, we use that union symbol. So this graph is negative in 3 different sections, from negative infinity up to negative 7. If it comes before this, out to the left of this, remember we read the graph from left to right, we'll always start with negative infinity for both of these. So from negative infinity up to here, that's negative. It's negative again from negative 2 to 5. And it's negative again from 11 to positive infinity. Where is it positive? Between negative 7 and negative 2. And between 5 and 11. Alright, so you might want to write that down, take a glance at it, and we will go back and look at what we're being asked for. So let's look at the graph. We need to know where the x-intercepts are. Well, in this one, we just happen to have a point that is both. It was not only it's a maximum, but it's also an x-intercept. And here's the other x-intercept. The x-intercepts are on the x-axis, remember. So these are my x-intercepts. Now this one's interesting because it is negative up until it gets to this point, but then it's actually also negative after this point. So intervals of increase and decrease, it always switches back and forth. Here it might actually stay negative after it goes from 0 up to 0, after it goes up to the x-axis. So on this one I'm going to say, let's see, the x-intercepts are at negative 1, 0, and 3, 0. And you could just say at negative 1 and 3. Alright, so that's me, I filled them in right there. And then where is it positive? Let's see. It's positive only after 3. It's only positive from here to the end of the graph. So from here to positive infinity. So I'm going to say from 3 to positive infinity, my graph is positive. It's above the x-axis. Now, where is it negative? Well, kind of everything up to there, but if we're being really specific about it, technically it's not negative here, because 0 is not negative. So if I were being picky about it, I would probably say from negative infinity up to negative 1 it's negative, and from negative 1 to 3 it's negative. Those are those two spaces. So from negative infinity up to negative 1, and from negative 1 to 3. My x values are, my y values are negative in both of those areas. But it's not at negative 1. So that's why this does not include, this kind of jumps over negative 1. And the last thing we need from this graph is the y-intercept. Where is it? It's right here. Y-intercept is 0, negative 3. So that's easy enough to just write in here. Alright, so now that you've seen me go through all of this with number 3, okay, go back to Desmos and put in this graph for number 4 and see what you can fill in. There's going to be a few things that you could fill in even before you look at the graph, like maybe the degree, domain, end behavior. Those 3 things you could fill in before looking at the graph. This time you can't fill in the range before looking at the graph because it's going to be one of these. So you do need to know where that lowest point or the highest point is to write the range. Okay, so this is a good time to hit pause, go to Desmos, do your graph. Okay, spoiler alert if you want to try to figure out what you can see before you go to the graph, because I'm about to show you. Boom. These things I can tell before I've even graphed. I know the degree is 4, which is even. I know the domain is all real numbers. And I know that both ends are going to point down. Even degree means both ends go the same way, and this negative right here is what tells me that they both point down. So these are both negative infinity. Alright, next thing I'm going to go to the graph. So if you want to hit pause, do it. Alright, here's what I see here. Like I thought, the two ends point down. So that tells me I'm going to have an absolute minimum, meaning I'm going to have a highest that the y ever gets. It looks like it might be a tie between these 2 points, so let's just check out both of those points. Yes, so the absolute maximum, I think I said absolute minimum, excuse me, absolute maximum, the highest y ever gets, is 4.5. So that tells me something about my range. So let's come over here. If my maximum is 4.5, and it opens down, then the range goes from negative infinity, that's the lowest it could be because it's pointing down forever, up to 4.5. Okay, just in general, thing to notice here, oops, wrong cheat sheet. If it opens upward, then your range is going to start with the number and then go to positive infinity. If it opens downward, your range is going to start with negative infinity and then go up to the number. All right, so next up, do we have any minima? Well, yeah, we've got a local minimum right here. The local minimum is -8. Okay, and by the way, I'm going to go ahead and specify on my page that the -8 is a local minimum or relative, but this is an absolute maximum. All right, so now these go with our intervals of increase and decrease. So let's look at where that's happening. It starts out, if I jump on the graph at the left, I have to have, my pencil would be moving. This is me drawing it. Think about tracing it or drawing it. My pencil would be moving up. So it starts out with an interval of increase until we get to this point. Now we're going to use the x value. Whenever we're doing our intervals, we're using the x value. So from negative infinity up to -2.581, it's increasing. Then it starts decreasing. I'm going down from -2.581 to -1. So that's my next turning point. Then it'll start going up again. So from -1, increasing to 0.581. And finally, from 0.581, going on forever. Oh, it was letting me trace it there for a second. These are going down, down, down. The y values are going down. So that is to negative infinity. Okay, so I need to jot these down. All right, so this is what those intervals of increase and decrease look like when I have them written out. Remember that anytime you write negative infinity, it comes first because we're moving from left to right. So if you start on the left, and left to right is always smaller to larger, so positive infinity is always on the right of your interval. Next up, x-intercepts and y-intercepts. So let's go find those. Let's look at the difference between what we have been looking at and what we need now. We don't need any of these points that are labeled right now. Let's click off of those. We need these points. We need to know where the graph crosses the x-axis or the y-axis. And it just so happens that the place that it crosses the y-axis, which is right here, is also a place that it crosses the x-axis because it goes through the point 0, 0. So here are my x-intercepts and y-intercept. So x-intercepts -3, 0, -2, 0, 0, 0, and 1, 0. I've got 4 x-intercepts. Then I also have 1 y-intercept. You'll always only have 1 y-intercept if you have a function. Okay, here I've got those written in. And then the next thing I need to do, and this is the last thing I need to do, is figure out where is it positive and where is it negative. And remember, this is where it changes from positive to negative, is when it crosses over the x-axis. So basically those points I'm looking at, where does it go from positive to negative or negative to positive? It looks to me like this graph is only positive between -3 and -2. And then over here between 0 and 1. Listen to how I'm describing those. Just looking at the x values. From -3 to -2 it's positive. From 0 to 1 it's positive. That's where the graph is above the x-axis. So that means from negative infinity up to -3 it's negative. That's this region right here. And from -2 to 0, that's in between there, it's negative. And then finally from 1 to positive infinity, it's negative there as well. So let me write those in and I'll be done. So remember, these intervals are often very closely tied together. In this particular graph, there's no bouncing back, so it crosses over every time it touches the x-axis. So it's going to be bouncing back between, it's not bouncing back in terms of the graph, but my intervals will be going back and forth between negative and positive. So if it's positive here, that means it's before it gets to that it was negative. And then it's positive from -3 to -2. So the next interval for negative would be from -2 to 0. It must be negative. And then from 0 to 1 it's positive. And then from 1 to infinity, it's negative. And I'm not just guessing that from the numbers. I did want you to see the connection there, but I'm also looking at the graph, and that's what I got when I saw the graph. And I hope this has helped. If you are just learning to do this, make sure you watch whatever parts of the video you want to watch. Make sure you go back and rewatch. Make sure you go back and copy down any information that you need to from those little info cards that I made. And thanks for watching. Bye.